Okay, Unit 14, second to last one that we're going to do for this year. On acids and bases. So let's start talking about acids and bases. So, what is an acid and what is an acid and what is a base? A acid is a solution that has a higher concentration of H plus ions. Your hydrogen ions are usually associated with acids. A base is a solution that has a higher concentration of OH minus ions, and your OH minus ions are called hydroxide ions. So acids are going to have hydrogen ions, bases are going to have hydroxide ions. And what you're going to have is, you're going to have your concentration is going to act as a gradient. So it's not going to be all or nothing. It's going to be either very acidic, slightly basic, very basic. So you can basically have a gradual shift from being an acid to a base. So what you're going to have to realize and what you have to understand, what concept you have to understand is that if something is acidic, you have a higher concentration of hydrogen ions. So looking at this picture, if you're over here on the left-hand side, then you have a higher concentration. You have more of your hydrogen ions. As you move from left to right and you come over here, then your hydrogen ions, your concentration of hydrogen ions is going to decrease, and your concentration of your hydroxide ions, which is OH minus, your hydroxide ion concentration is going to increase, causing you to go from an acid to a base. Also, your H plus ions, your acid ions, can also be represented by this molecule called H3O. So H plus and H3O are both going to show you that you have an acidic solution. The brackets around the letters, so these brackets mean something. Those brackets mean concentration of. So if you see this symbol, H plus with two brackets around it, that is saying concentration of H plus. This is saying concentration of OH minus. So the brackets just mean concentration of. Okay? So over here you have a high concentration of H plus and a low concentration of OH minus. Over here you have a high concentration of OH minus and a low concentration of H plus. Properties of acids and bases. So you do need to know the different properties of an acid versus a base. So typically, your acids are going to have a tart or sour taste. They are going to cause blue litmus paper to turn red. They are corrosive towards metals, and they conduct electricity very well. Litmus paper, I will show you what it looks like next week. It is just a special colored paper that if you either have blue litmus paper or you have red litmus paper. If you put a piece of blue litmus paper into an acid, it will turn red. If you put a piece of red litmus paper into a base, it's going to turn blue. If you put a piece of blue litmus paper in a base, it won't do anything. It'll stay blue. If you put a red litmus paper in an acid, it won't do anything. It'll just stay red. Yes?
What kind of acid do I have? Like, I have acid that, like, burns really hot. Like, do you have this, like, we used to have this little shed on the cement slab, and we destroyed the shed, so now it's just a cement slab,
Okay.
and there's, like, rebar nails, like, sticking out of the ground.
Okay.
So, pour acid on them and burn them down.
Oh, I didn't know you could do that.
What kind is that?
What's the name of it?
Yeah.
I have no idea.
Wait, does hydrochloric acid do that?
I don't know if hydrochloric acid is acidic enough.
What, is there another kind of acid?
There's a-
hexachloric?
There's hydrochloric acid, sulfuric acid, phosphoric acid. There's a bunch of different acids. But I didn't know it could do that. But I'm assuming if it is, then it's very acidic. If it's gonna break down metal.
Yeah.
It's gotta be very acidic. So just make sure you don't touch it. Anyway. Alright, so those are the properties of acids. And then you need to know the properties of bases. So typically bases are going to have a bitter taste. They're going to feel slippery. They're going to cause red litmus paper to turn blue. They can also conduct electricity, just not as well as acids. And then finally, they are going to be caustic towards tissue. So, does anyone know what caustic means?
Caustic.
Like the
So, do we know
Like
what the
that,
word
dude.
caustic means?
I can see.
like poisonous or something like that.
Huh?
It's like poisonous.
It is the same effect, so it is bad. So caustic, bless you, means that it's going to degrade or break down organic material.
Yeah.
So this is why most, if not all of your cleaners are going to be some form of base. So some concentration of a base. So you have more basicity and less basicity. You have a more concentrated base solution. But all of your cleaning products are going to be base solutions because base solutions or bases are going to be caustic towards organic material. So they're going to break down organic material. So all of your dirt, grime, and all that, that's all organic material. So those cleaners, those bases, are going to break that stuff down and get rid of it. Yes? You have stomach acid in your stomach.
What kind of acid is that?
Stomach acid.
Okay, so what about like when you like throw up acid and it like burns the back of your throat?
That is the acid wearing away at your esophagus, and
That's my stomach acid.
that's your stomach acid causing damage to your esophagus.
Oh, fun.
Mm-hmm. So heartburn. When you have heartburn, that is when stomach acid comes out of your stomach the way it's not supposed to. So it comes up, and that's why you feel it here because it's coming out of your stomach. So it's not anything to do with your heart, actually. It's stomach acid coming out of your stomach up your esophagus. And then eventually, over time, if you have that happening frequently, then you can have, what is it called? I just had it. Reflux. What is it? Yes, acid reflux disease.
Acid reflux.
So acid reflux disease is basically the same thing, but it's further up. And essentially what you can have over time is the stomach acid. You've had stomach acid in your esophagus so often and so much that it starts to wear a hole through your esophagus, which is not good. So
Wait, where's your esophagus? Isn't that the little bowl?
it's the tube, your whole tube. So your
what's
throat.
That? The uvula, right?
Yes, the throat, like right here. Yes, yes. All right. So the rule of thumb is, if you're not sure if something is an acid or a base, the first test that you should do on that should not be to put it in your mouth and taste it, because yes, acids are usually sour and bases are usually bitter. But if you have no idea what that substance is, then don't put it in your mouth. Okay?
What about like battery acid?
No, let's not do that.
No. I mean like, is that like dangerous?
Yes. Yes, battery acid is very acidic.
Louis, you should try it.
I mean, I have a golf
Please-
cart that
please
has
don't.
battery acid on top of it.
Please don't.
If you look at
All right, so here are, guys, here are 2 columns of acids and bases that you have to memorize. So you have to know the name and the formula for all these acids and all these bases.
Wait, we don't have to memorize this.
You have to have it for the test. The test is going to be multiple choice, yes. Yes. So, this should be fairly easy. I mean, yeah, you can. It'll be on Canvas though. All right.
Can I use the card on Canvas or anything?
All right. So hydrochloric acid is HCl. This is not HCI. This is not a capital I, because if you have HCI, that means you have a compound made out of hydrogen, carbon, and iodine, and that will never happen. Okay? Because it doesn't. So hydrogen, carbon, and iodine will not make a thing. This is hydrochloric acid. This is HCl. That is a lowercase l. Okay. So that's hydrochloric acid. Nitric acid is HNO3. Sulfuric acid is H2SO4. Carbonic acid is H2CO3. Acetic acid is how you say that word. Acetic acid is CH3COOH. They write it like this because the molecule of CH3COOH looks kind of funky in that this oxygen is kind of sticking out because it has a double bond attached to it. So that's acetic acid. Phosphoric acid is H3PO4. Potassium hydroxide, sodium hydroxide, lithium hydroxide. These are all bonds between a column 1 metal and a hydroxide ion. So your column 1 metals all have an oxidation number of +1, and your hydroxide ion has an oxidation of -1. So remember, when we write formulas, we take our oxidation numbers, we crisscross and bring them down. And then we get rid of our signs, and we get rid of our number 1s. So if you have a column 1 metal attached to a hydroxide ion, then it is just the metal element and then OH. So potassium hydroxide is KOH, sodium hydroxide is NOH, lithium hydroxide is LiOH. And then if you have a column 2 metal, because your column 2 metals have an oxidation of +2, your OH ion still has an oxidation of -1. So when you crisscross and bring those down, the 2 from the barium and the 2 from the calcium are going to go on the outside of the OH. So that is why you need a parentheses around the OHs, because you have 2 OH molecules. Okay? So if you did not write that with a parentheses, if you just wrote BaOH2, that's a completely different substance. That is, so BaOH2, that tells you that you have 1 barium, 1 oxygen, and 2 hydrogen. That is not correct. You have to write it as Ba parentheses OH parentheses 2. That is saying that you have 1 barium, 2 oxygens, and 2 hydrogens, and because you have 2 hydroxides. So this one, not this one. Okay? The same goes with calcium hydroxide. Calcium hydroxide is CaOH2. And then you have ammonia, which is the odd man out because it is NH3. So ammonia is NH3, but it is a base. So it does not have an OH ion, but it is still considered a base. All right. So then the question is, how would you write magnesium hydroxide in the formula? So magnesium is Mg. It's a column 2 metal. So that means you need a 2 on the outside of your hydroxide, because you're writing magnesium hydroxide. So it's Mg parentheses OH parentheses 2. So any column 1 metal hydroxide is just going to be the element and then OH. Any column 2 hydroxide is going to be the element, OH in parentheses, and then a 2 outside the parentheses. Ammonia is NH3, ammonium is NH4+. So you just add on an extra hydrogen. All right. So now what we have the pH scale. So here's our pH scale. Your pH scale is a scale between 0 and 14, where 0 is your very, very, very acidic substances, and 14 are your very, very, very basic substances. And then in the middle, at about 7, you have what are called your neutral substances. So those are neither acidic nor basic, they are neutral, and that is at 7. Yes?
Do we have to write this down?
You have to know the pH scale. You have to know where the acids are, where the bases are, and where the neutral is on the pH scale.
Oh, Jesus.
Okay. So, yes. So anything between 0 and 7 is basic. 7 exactly is neutral. Anything from 7 to 14 is basic.
Oh wait, battery is like the worst one.
Yeah.
Take a bite.
Good thing I didn't try that.
Very, very acidic. It's even more acidic than your stomach acid. So your stomach acid is pretty acidic. Lemon juice, as well as all of your other citric juices, so orange juice, grapefruit juice, all those other citruses are also going to be very acidic. Vinegar, tomato juice, coffee are pretty acidic. And then milk is slightly acidic.
Tomatoes?
Tomatoes are acidic. Mm-hmm.
Okay.
Yes. And then water, true natural occurring water, so if nothing's added into it, because bottled water has stuff added to it, but naturally occurring water has a pH of 7. Okay, or it should have a pH of 7. If it doesn't, or if it's not very, very close to 7, then there's stuff added in there to cause the pH to be different. And then your basic solutions include blood, baking soda, stomach tablets, and then notice how you have all of your cleaning supplies over here as very, very basic solutions. Okay? So ammonia, soap, bleach, drain cleaner, those are all basic solutions. So, also realize that your pH scale is your pH scale has to do with the concentration of your OH ions or your H plus ions. So again, your H plus ion concentration is found more in your acids, and your OH concentration is found more in your bases. So at the end, towards the end of the unit, we are going to have some math where we're going to look at the concentration of these two and calculate the pH given concentration numbers, or you're going to calculate concentration numbers given the pH. So there is some math involved. I do believe that the formula is given to you on your formula sheet. So it's going to be like the math that you did last unit, where you are given the formula, you plug in the numbers, and you solve for the unknown. I think.
Yeah.
Yes. Okay. So that is what.
Log,
Yep.
brackets. Yeah.
So that is what we will do closer to the end of the unit. Okay. So, I was going to ask you what those were, but realize that all of these, so to the left of 7, from 0 to 7, these are all acidic. From 7 to 14, these are all basic. If it is 7 exactly, then it is neutral. If it is not 7 exactly, then it is not neutral. So if it's 7.1, it is slightly acidic. If it's 6.9, then it's slightly basic. Okay? Alright, so what is this? What is this?
Hydrochloric acid.
That's hydrochloric acid. How do you write nitric acid?
HNO3.
What is H2SO4?
Sulfuric acid.
Sulfuric acid. How do you write carbonic acid?
CO3.
What's CH3COOH?
H6.
Acetic acid. What is phosphoric acid? How do you write it?
H3PO4.
Okay. How do you write potassium hydroxide? KOH. What's NaOH?
Sodium hydroxide.
Sodium hydroxide. How do you write lithium hydroxide?
LiOH.
What's BaOH2?
Barium
How do you write calcium hydroxide?
Parentheses, CA, parentheses, 2, parentheses.
And what is NH3?
Ammonia.
Very good. Alright, so now what we're going to have to do is, I am going to give you, or what you're going to have to do by the end of the unit is, I am going to give you a reaction, and in that reaction, you have to pick out the acid, the base, and then what is called the conjugate acid and the conjugate base, and you have to tell me what the conjugate acid-base pairs are. So, 5 questions given 1 reaction. Alright, let's do this. So, what we first have to do is we have to figure out what is an acid and what is the base. Given our reaction, which one is the acid and which one is the base. So we have, I think 3 models. So we have 3 models that we can use. One is going to be the best that we're always going to use, but we have to know where we started from before we can figure out what the best one is. So the first model that was introduced is called the Arrhenius Model. because Savante Arrhenius in 1883 came up with it. And he figured out how to determine which is an acid and which is the base. So in a reaction, an acid is going to be something that contains hydrogen and that is going to ionize to produce a hydrogen ion. And then a base is a substance that contains an hydroxide ion, a hydroxide ion, and it's going to, it contains a hydroxide group and produces hydroxide ions. So if we have the dissociation or the breaking down of hydrochloric acid in the gaseous form is going to produce hydrogen ions and chlorine ions. So because this substance produces hydrogen ions, this substance is an acid. If we have the dissociation or breaking down of NaOH, that is going to make a sodium ion and a hydroxide ion. So because this substance breaks down and produces a hydroxide ion, that substance is a base. So that is how the Arrhenius model is used to determine what is an acid and what is a base. If it produces a hydrogen ion, it's an acid. If it produces a hydroxide ion, then it's a base. So for this example, we have this reaction. So we have the reaction between water and ammonia, so NH3, and we are going to be producing our OH minus ion and our ammonium ion. So given this reaction, you are going to have to figure out what is the acid, what is the base, what is your conjugate acid-base pairs, and then what is your conjugate acid and your conjugate base. So, first of all, given the Arrhenius model, let's figure out which one is the acid and which one is the base. Now, you have parent acid and parent base, or you have conjugate acid and conjugate base. Your conjugates are always going to be in the products. So these are always going to be conjugates. Your parent acid and your parent base are always going to be the reactants. These are always products. Okay? So the reactants are always going to be either your parent acid or your parent base. Your products are always going to be your conjugate acid or your conjugate base. So our first step is to figure out which one is the parent acid and which one is the parent base. Okay? So if we are thinking about the Arrhenius model says that an acid is what? What would an acid produce if we had an acid? A hydrogen ion. Do we see a hydrogen ion anywhere in our reaction? No. So we can't definitely say that one of these is an acid. So, what about a base? If we have the Arrhenius model, what does the Arrhenius model say is a base?
Hydroxide.
The OH, the hydroxide ion, is produced. Do we have a hydroxide ion in our reaction?
Maybe. Oh yeah, the HO, right?
So it's right here.
Yeah.
So, in order to figure out what the parent acid or parent base is, so in this case we're trying to figure out what the parent base is, we need to figure out which one of these reactants produced this base. So where did this come from? Actually, no, I did that wrong. Okay. Okay, so this is an OH minus ion. So because it's a hydroxide, what is it going to be? It's going to be a base. So this is your base. Now, because it is on the product side, it's going to be a conjugate base. Your conjugate substances are always in the products. So your OH minus ion is going to be your conjugate base. Now, when you have, so your parents, you have two parents and you have two conjugates. One is going to be one thing, so one's going to be an acid, and one's going to be the other thing, so one's going to be a base. So, looking at your products, if this one is a base, what is this one going to be? This one is going to be an acid. So one has to be one thing, and one has to be the other thing. These are both reactants, so they both have to be what? Conjugates. So this is going to be your conjugate base because it is a hydroxide ion. If this is the base, then this has to be the acid. Because it is an acid, in your product side, it has to be a conjugate acid. So now, let's figure out which one of our parents is the acid and which one is the base. How you're going to do that is now you're going to figure out what your conjugate acid-base pairs are. So your conjugate acid-base pairs are a pairing between a parent and a conjugate, which they have to be made out of the same thing. So what you're going to do is you're going to realize that this has hydrogen and oxygen in it, and this has a nitrogen and a hydrogen in it. So you're going to pair up these two with its corresponding partner on the left-hand side of the arrow. So if this one has only hydrogen and oxygen in it, you're going to look at these two and find the one that also has hydrogen and oxygen in it. So which one is the partner to this one? This is its partner because this has oxygen and hydrogen, and this has oxygen and hydrogen. So these two things are one of your conjugate acid-base pairs. Conjugate acid-base pair. Okay? We always are going to have at least two pairs. So we have to find the other one. This one has a nitrogen and a hydrogen, and this one has a nitrogen and a hydrogen. So those two are going to be your other conjugate acid-base pair. So here is one conjugate acid-base pair. Here's another conjugate acid-base pair. So now that we know what our pairs are, now we can figure out which one is your acid and which one is your base. Okay. So if this one was your conjugate base, whatever its partner is has to be the opposite. So if this is your base, its partner is the what? Acid, the parent acid. So this is the parent acid. Sometimes, or usually you'll just call it the acid. Sometimes you can call it the parent acid. All right? If this is your conjugate acid, its partner is going to be the what? Parent base. Remember, conjugates are over here, parents are over here. So this is your parent base. So that is what you're going to have to do. I will give you a reaction, and you're going to have to tell me which one is your acid, which one is your base, which one is your conjugate acid, and which one is your conjugate base. And then you're also going to have to tell me what two or make up your conjugate acid-base pairs. Okay, we'll stop there for today. We'll do more next week.